Okay, hi guys. I'm very glad to see you guys again. I can see all your names on the list. Okay, let's start our today's class. I think our main task of today is to finish the final content of this chapter, plane trusses. If we still have time after we talk about this topic, plane trusses, how to calculate its internal forces. Then we'll do some exercises together. After all this, if we still have time, maybe we'll start a new chapter, which also the last chapter of this part, statics. We'll talk about fraction, right? Actually, 摩擦. So first, let us talk about these plane trusses together. Actually, I think in Chinese we call this. I'll change my point into a pen, which I can write something on screen. I hope my voice and picture will be okay for you guys. If there's some problem, please let me know. Okay. So let's start. I cannot find my pen. Where is my pen? Oh, sorry. I do not plug the USB, so it cannot detect my pen. Maybe, okay? Okay, here you go. You can see I am drawing line here. So actually plane trusses, we Chinese call that plane means 平面, and trusses we call that 行架, 横架. So actually it's a kind of structure, just like these two pictures. So a truss is the structure that is made of straight slender bars, straight slender bars. When we look at these three word, we immediately think about maybe all these bars will be a 2-4 bar, right? That are joined together to form a pattern of triangles. So you guys can see this picture more like a very simple bridge, right? And this is the structure when we build a house, especially in farmer, maybe in my hometown, people will build a house you like this kind of structure. So all these constitute like this a lot of triangles joined one to each other. We call that a truss, especially a plane trusses. So actually, they are very famous structure all around the world. Maybe you guys will know that. Actually, I don't know how to use English to describe this, but I know it's in France, Eiffel Theater, right? It's a famous tour in France. Am I right? And this may be a part of a very big braid, right? So there are a lot of structures constituted by this kind of truss, in engineering. So very famous, a beautiful scene, right? Like this, like this. You guys can see a lot of. Maybe this one should be in maybe in Britain, in UK, right? And in the plane, a lot of uh, uh, application engineering, we can find this kind of truss. So after we see all these pictures, if we try to do some calculation, we should give the 3 assumptions. So actually in Chinese, we call that 理想化假设. So actually these assumptions maybe induce some errors, maybe induce some errors, but these errors maybe is very little, very tiny. It will not have an enormous effect or side effect to our conclusion. So we can give these three assumptions. But when we give this so-called 理想化假设, it can simplify our process of calculation, you know? So there are 1, 2, 3. So the width of the members are negligible. That means we do not consider its gravitational force of each member, you know? So if this is the very straight slender bar and we do not consider its width of the members, so it will be a two-force bar, right? And the second assumption is all joints are pin. You know, actually, some actual joints may be not pin, but we look at our pin, right? And the third one, the applied forces. Actually, this is some kind of active forces. You know, active forces. So it all act at joints. You know, so here when we talk about joints means maybe we can also use another word, knot. You know, in China we call that 节点. So all the applied forces will acting at joint, like here, like here, like here, like here, right? So it will constitute a very simple structure. So maybe we can find there are a lot of triangles joined one to each other. So we call each member its element. We call this very little circle will knot or joint, right? If we have some applied forces, will all applied on some given point like this. Maybe we know this is 5 kilonewtons. So before we do some calculation, we talk about these three assumptions. This will simplify our calculation. But when we talk about these plane trusses, what will we do? What will we do? Let's see. So actually, there are three kind of trusses. So one is the simple one, simplest, right? So here is the fixed support, and here is the roller support, you know? So according to the three assumptions we just mentioned at last page, we can get conclusion, you know? This is a very important conclusion. Each member, like here, 1, 2, 3, right? Like here, 1, 2, 3, 4, 5, as so on. Each member of a truss is a two-force body, you know? If a body is a two-force body, we know it only have two force acting on its 2 points. And the action line of these two forces will along the line which link these 2 points, right? It may be stretched by these two force or maybe pushed by these two force. So if a body is a two-force body, it will quite simplify our calculation, right? So this is a very important conclusion. And calculation of the forces in the members of a truss. So there are two methods. One is the method of joint. In China, we call that 节点法. 节点法. And the second method, we call it the method of section. We call that 截面法. But before we introduce these two methods, we should know what will we do? What we try to figure out, use this method or this method. Actually, we are trying to calculate the internal forces of each member, you know? Each member, because we know that each member will be look at a two-force body. But what is its internal force? internal force, internal force. So maybe next semester I will teach you guys another course called engineering mechanical second. So at that time we are going to talk about the deformation. So our body will have some kind of deformation according to different loads. Actually we will give a conclusion that different internal force will induce different kind of deformation, right? Actually, at that course in Chinese we call that 材料力学, right? We'll talk about internal forces, a lot of different kind of internal forces. So here we just talk about very, very simple one because all the member of a truss is a two-force body. So you guys, please follow me. We just select one of the members to talk about. So maybe this bar AB, just one of member of a plane truss, it is a plane truss. So according to our assumption, it will be a two-force bar. So it may be, if it is a two-force bar, it will only have two forces acting on point A and point B. Actually, at point B and A will be two knots, right? Two knots, 两个节点, two knots. So because these two forces will let this bar AB in the state of balanced. So I write here Chinese character 平衡 means equilibrium, means balanced condition, right? So first we'll know there are only two forces. Then we know the relationship between these two forces. So we always denote with FAB. So these two forces, if this bar is a two-force bar, always have same magnitude, opposite direction, and collinear, right? And if this bar AB is a two-force bar, it may be stretched by this AB. We call that 两端受拉, 两端受拉. In this state, this FAB and this FAB try to elongate a little bit of this AB. Although we know because we treat AB as a rigid body, it never have any deformation. But anyway, these two forces will try to let this bar will be stretched or elongated a little bit, right? We call that 两端受拉. Another case is FAB, and this FAB try to push this A and B into one point. Actually, we can call that in Chinese 两端受压. So this condition, these two forces try to let the length of AB shorten a little bit. Although this will not happen because we treat this AB as a rigid body, but these two forces are trying to put them together, try to shorten the length of AB a little bit. So it's only two cases to select for a two-force bar. Maybe 两端受拉, maybe 两端受压. Only two states. It only can be in one of the state. We have no any other options. So that is a two-force bar. Then we'll talk about what is internal force. So imagine we have a plane. We denote it with 1, 1. So we have a plane which can cut this bar AB into two parts, the top one and the bottom one, right? So because actually, because this FAB acting on B and A and let bar AB in the state of equilibrium, in the state of balanced. So if we just select a part of only one part to be an object to be studied, it also should be in the state of balanced. So like this. So we can just select this part to be studied. So this one should be FAB, right? So, but when we how to say we eliminate this part, but we should use the force to behave its application from this part to this part, right? Actually, because this kind of application, which will let this part and this part into a whole part, right? So actually this is the so-called internal force, you know? So if this part, so this is point B, this is point B, and this is, maybe I just arbitrarily select a position, use the plane, imagine cut this bar AB into two parts, you know? So we just select this part to be studied. Then we should give a force. This force behave the application or the action from the bottom part to the top part, you know? So this kind of action is so-called internal force. So actually from the equilibrium condition, we can very easily know that actually FAB minus F1 should equal zero because this little part also should be in state of balanced equilibrium, right? So we can say actually internal force equal FAB, right? So it tells us how to do the calculation. Our main task is to calculate each member of the truss its internal force. Actually, we do not need to cut each member into two parts because its internal force will equal to the force at the knot. So that's why we have the method of joint or method of knot, you know, KNOT, 节点法. And also we also have a method of section. Then I will introduce these two methods to you guys and how to find all the internal forces of this member from the same plane truss. No? So until now, all the content I have talked about, can you guys understand me? I think should be yes, because it's not difficult, right? Can you?
Yes,
Okay. I hope
yes,
you
yes,
get.
Sashi.
Okay, well, let's move on. So let's see an example. So determine the internal forces on every element. So you know we have a very beautiful plane truss because it's symmetrical from this vertical line. Actually, it is a vertical member. Had the number 3. So we have 1, 2, 3, 4, 5 members. So we have an active force P. Its magnitude is 10 kilonewtons acting on knot D, right? So our main task is determine the internal forces on every element. So we'll talk about how to use the so-called method of joints of our method of knots. So the first process our solution, it should be first we should figure out the type of constraint and using the equilibrium condition to find its magnitude. So you guys please follow me together. We find actually at point A, there is the roller support constraint. So this kind of constraint only have one direction of reaction force. We use NA to denote this force along this direction. right? And this at point B, it is the fixed support between these two members and the frame, you guys know the frame. Actually, frame never move, right? It's fixed all the time. So because it is a fixed pin, it have two reaction forces. So one is XB, another is YB. So our default coordinate system always positive X point to right and positive Y point to up, right? Upward. So the first task, we should use the equilibrium condition of a plane force system to calculate an AYB and XB. So do you guys still remember the three equations of plane force system? So we have sigma x equals 0, right? We have sigma y equals 0, and we can select some point. We have sigma MAF equals 0. So according a plane force system, we have three equations, so we can solve three unknowns. So here you can see unknowns 1, 2, 3, right? So that's the first process. Study the whole structure. Actually, it means we select the whole structure to be an object to study. Then we should remove all the constraint between the structure with the frame. So here is the frame, here is also frame. But when we remove all the constraints, we should use, some reaction forces accordingly to denote or to behave as action to this structure, right? So then after we give this false analysis, we can give this first equation. We have sigma x equals 0. So you can see from this whole picture, there are only xb along x direction. So all the other things. So, when we select the whole structure as the object to be studied, all the internal forces at point C, D is internal forces. We do not need to consider that, right? So when we give sigma x equals 0, it's only xb. There are no other forces along x-axis. So we have actually xb equals 0, right? So let's continue. This time we will use this moment equation, right? So we select sigma a f equals 0. So when we select point A as a point to give this equation, moment equation, then we do not need to consider NA, right? Because actually NB is 0, so we can use this equation to find magnitude of YB. So you guys please follow me together. So when we give sigma MAF equals 0, we can from rightmost to the left. So this YB, it will have a moment to point A with CCW direction, So CCW direction actually is counterclockwise direction. It will be positive, right? So we give that YB times its distance from this action line of this force and this point. So this will be 4 meters. So we have 4 meters times YB, which is positive. And there only another force acting at point D, but its direction is downward direction. So this P will have a moment to point A along CW direction, clockwise. So which is in Chinese we call that 顺时针, along the direction of a clock, 顺时针. So it will be negative. So we have minus 2 because it's 2 meters times P equals 0. Then you can very easily get the magnitude of YB. It should be what? YB should be half P, right? Half P. P equal 10 kilonewtons, so our YB equal 5 newtons. Then only NA is unknown, so we can use, maybe we can use sigma MBF to find NA. Actually, we also can use the last equation, this one. So we can use, maybe I can write here, sigma Y equals 0. So please, you guys follow me together. So we have NA, right? NA minus P because it's downward direction plus YB because it's upward direction equals 0, right? So we can very easily find actually NA will equal P minus YB, and YB actually is half P, so NA actually also half P, right? That's how we find the three reactions, right? So maybe we'll treat different kind of trust, but the first step we will always try to figure out its reaction forces like this. So maybe I will erase all the things on the screen. So maybe you can see it very clean. So after this, after this step one, we'll try to find each internal forces of the element. Then we can select each point or each knot to be started. See? So we'll study the joints A, C, D one by one. Maybe some you guys will have a question. Why teacher do not select joint B? So you guys can find actually when after we select A, C, D, actually we have the internal forces of member 4 and member 5. So we do not select B to do because all the unknowns of these 5 internal forces we have finished figure out is magnitude, right? So let's see the first joint or first knot A. So because actually we have NA, its value will be half P, which is 5 kilonewtons here, right? So we will treat all the members will be stretched at 2 points. That means we will treat all the members as 两端受拉的二力杆 because all the members will be 2 force bar 二力杆 and we think all the bars will be 两端受拉 right 两端受拉 so you can think about that. If this bar AC will be stretched from point A and point C, then from the action and reaction point of view, this bar AC will try to stretch this point A too, right? So if you push me, I will push you. If you stretched from some point to this knot, then this knot will stretch at the same point to this bar, right? So here, actually, S1, S2 means two forces along two different directions because of the internal forces of this AC and CD. Actually, we can from this knot can find the internal forces of AC and AD indirectly, indirectly. So actually, can you guys, you can find when we select knot A as the object to start it, because this knot also should be in the state of balance, an equilibrium condition. So it's very simple. Do you guys still remember playing concurrent? Concurrent. It's hard to write things. concurrent force system, right? Force system. So do you guys still remember in Chinese we call that 平面会焦立系? So because this kind of force system is equilibrium condition with only two equations, one is sigma x equals 0, another is sigma y equals 0, which is very simple. So it only have two equations. We can only find two unknowns. So you can see at this point A, this one is direction, the magnitude is known. So we S1 along this direction, S2 along this direction. So we only need to use these two equations to find the magnitude of S1 and S2. You see? So we have, when we give this sigma x equals 0, we know that this angle is 30 degrees. So we have sigma x equals 0, so we have S2, because this one we assume we have a positive assumption because it's along the positive direction of x axis. So S2 plus, because S1 projection onto this axis, horizontal direction, will be S1 times cosine 30. So we have this S2 plus S1 cosine 30. Then we can use another direction, give this equation sigma y equals 0. So we have an A plus S1 sine 30, because this force projection onto this axis also have positive sign. Because S2 is direction perpendicular to this vertical direction, so it will have 0 projection onto this axis. See? Can you guys understand these two simple equations? It's very easy. It's very easy to understand, right?
Yes.
Yes, there you go. So we can just, we know NA is 5 kilonewtons. We can find the cosine 30, sine 30 using our calculator. Then we can find magnitude of S2 and S1. Right? So you guys can find, after we select joint A as an object to start it, we find the internal forces of member 1 and member 2 indirectly. Then we can continue this process. Let's move on. So this time, we will select point C or joint C as an object to be started. So if we denote this F1 prime, because we have S1 equal minus kilonewtons. It's fine. Don't worry this sign. You just use the sign and the value together is okay. So if we have S1 equal minus in kilonewtons, it means actually this member 1 not stretched from 2 points. Actually, it is pushed at 2 points A and C. But it's okay. So when we select C point or joint C as an object to be started, it S1 prime means S1 prime also equal minus 10 kilonewtons. You know, actually this is from the point, from the action and the reaction forces point of view, right? So here it is another plane concurrent force system. Only two force S4, S3 is unknown. So it can be solved. So once again, we can use this sigma x equals 0, sigma y equals 0. So this is original figure. So if this is 30, then here should be 60. Right? Here also should be 60. Why? Because this 30, this also 30. This whole structure is symmetrical along this medium vertical line, right? So we have, sigma x equals 0. So we have S4. S4 times cosine 30. Actually, cosine 30 actually equal sine 60, you know? Oh, actually, we can draw a 80 the horizontal line. This 160, this angle will be, right, will be 30. So we have S4 times cosine 30. These components have a positive sign, right? And this S1 prime times cosine 30 here, but its direction will be -1 because it's along the negative direction of x. So we have minus S1 prime cosine 30, right? So we have the first equation. Then we use sigma y equals 0. You see, actually this s third along the negative direction of y, so it's a minus s third. And this s1 prime and this s4 all have a component along the negative direction of y. So we have s1 prime cosine 60 actually is a sine. Cosine 60 actually is sine 30, right? So actually, because it tried to use this 30 and this 30. So if this x component is s1 prime and times cosine 30, then its y component will be s1 prime times sine 30, but it will have a negative sign, right? And also the same reason for S4 here. So we have this. So you can see substituting into S1 prime equal S1 equal minus 10 kilonewtons, right? After a little bit calculation, you can use these two equations to find magnitudes S3 here and S4 here. So we do not take our time to do the whole calculation. You guys can do it by yourself. It's very easy, right? You just need your patience and time, right? You can use your calculator. You can use MATLAB software, maybe, right? So you guys can look at this figure. After joint A and joint C, we only have member file, right? So once again, we can select D as a point. So because S2 prime, S1 third prime, also known, all known. This is active force which have magnitude with 10 kilonewtons, also known. So we only need to one direction equation to find sigma x equals 0. So it very easily find actually S5 minus S2 prime equals 0. So S5 will equal S2 prime equal I'm sorry, S second prime equal S second and equal what? We can find S second equal 8.66 kilonewtons, right? So we get, is that okay? So here is 8.66 and here it write 7.66. It should be 8.66, right? But it's okay. It's not a very big problem. I just hope you guys can understand this so-called method of joint, right? So the another equation of joint D can be used to verify, to verify the result of calculation. So you will find S1 prime, S third prime should equal P. Actually, we have S third. Yes, indeed, it is equal to P, right? So the solution of which is S third prime equal 10 kilonewtons is equal to S third. The calculation is accurate. I think all you guys can find actually this so-called the method of joint is very simple, but it's a little bit complicated. It takes a lot of time, right? So we have to select one joint to another. Then we can find all the internal forces of all the members, which constitutes this whole plane truss, right? This is how we use the so-called method of what? Joint, right? Method of joint or method of knot. Method of knot. So I hope you guys can totally understand that. So then we'll move on. So this time we'll talk about what? Talk about how to use the second method. It's second method of sections. So please, you guys look at this whole picture. It tells us knowing H, knowing A, and P. Please determine the internal forces on the element 4, right? 5 and 6. Can you guys figure out the big difference from this example from the last one? Can you guys find the big difference from this example from that example we just finished using method of joints? Can you? Actually, if you look at this example thoroughly, you can find this time it only need us determine some of the members its internal forces. You see, please determine the internal forces on the element 4, 5, 6. So in other words, 1, 2, 3, 8, 9, 10, 11, these members' internal forces it not be interested in. So it only focused on 4, 5, 6. So indeed, we can use, first we can calculate its reactions at point A and point B. Second, we can use the method of joint just from A, this one, this one, this one, this one, this one. Then we can finish and we can find all the internal forces of all the members of this whole truss. But there are a lot of calculation is not necessary because it only try to figure out member 4, member 5, and member 6, right? So is there any other simple method to let us just focus on the calculation of its internal forces of member 4, 5, and 6? The answer is yes, there is some kind of measure. So let's talk about that. So the solution is we always study the whole structure, determine the reaction forces. So once again, you guys follow me together, please. Because A is a fixed support, it will have two reactions with XA and YA here, right? And this point B also another roller support. It only along Y direction have NB. So before we try to using different method to determine the internal forces on the element 4, 5, and 6, we should figure out the value of XAYA and NB, right? So once again, we should use the three equations of a plane force system. One is sigma x equals 0, So we have XA, and then look at the whole force analysis picture. There are no any other forces along x direction. So once again, we find XA equals 0. Then we can select sigma FB equals 0. You guys can find, actually this time we try to find the magnitudes of YA. So let's try to give this equation by ourselves before the slide show the answers, right? So if we select B to the point of this equation, we can consider all the forces from the leftmost to right. So you guys can find actually this XA is action line will through this point B. So it will have 0 moment to this point. So in other words, we do not need to consider this XA. Actually, XA equals 0, right? We do not need to consider it plus 1, right? And this YA, please you guys consider its direction along upward. So it will have a CW direction moment to this point B. So we'll have minus YA times the whole length from point B to action line of YA. So there it be times 3 times 8, right? And we also have 2P. 1P is along the opposite direction of YA. So it will have a CCW direction to point B. So we have plus P times 2A and plus P times 1A, right? So there are no any other forces should have moment to point B. So this three, one sum will be 0, right? So we can eliminate out A, and this will, because this have minor sign, you can see we can find 3YA, right? 3YA will equal 3P. So this means YA will equal P, right? Can you guys understand? It's quite easy, right? Yes, great. I'm very glad to hear your voice say like that. Yes, teacher, I know. I know what are you talking about, right? And the final one is what we left. Yes, we should find magnitude of MB. Actually, we can use sigma MA equal 0. We also can use sigma Y equal 0 because XA, YA, we also know its magnitude. So you can see, actually, we use this sigma Y equal 0 here. So we have YA minus P plus MB equal 0, right? So you can find actually MB equal 2P minus YA. YA have 1P, so actually MB equal P. So actually, after all our calculation, you guys can find because XA equals 0, right? And this whole structure also have a symmetrical axis along this vertical line. So this 2P also symmetrical from this vertical line. So actually from the symmetrical point of view, so this YA should equal NB equal half total P. Total P is 2P, so this YA equal NB equal 1P, right? Can you guys understand what my meanings? Actually, from the symmetrical point of view, we can very easily find the magnitude of YA and NB, right? So I will erase all the things here. So actually, we have find NA and NB and YA. So this time we'll try to find internal forces of number 4, 5, and 6. So I find it's time for us to have a short break. So let us have a short break. We will restart our class at 11:10. Okay?
Okay,
So,
Rashid.
okay, have a rest, you guys. See you. Let's continue. So what is method of section? So you guys can find imagine section 1, 1 to cut the truss, this is not for real. It's imaginary. So I think the basic principle is that means maybe I can write here if the whole part is equilibrium, right? Then some part the sub may be subpart, right? Subpart also should be in the condition of equilibrium. So that's the principle of this so-called method of section. You know, it's very smart. So you guys follow me. So imagine we have a section 1, 1. It can cut this truss into two parts, right? The left one and the right one. And we only study the left part of the truss because the whole truss is in the state of balanced or in the condition of equilibrium. Then when we just study the left part, we should use some forces to behave the right part, its action to the left part. You know, actually, this action is the internal forces of member 4, 5, and 6. You know, so actually, we use this so-called imagining section 1, 1. So it's very interesting or very what 特别巧合 you know use this section 1, 1. It cut 4, 5, 6 into two parts already, right? So we can use S4, S5, and S6 to denote the three internal forces of these three members, right? So from this picture, you guys can find this XA known, YA known. P is the active force, of course, known. So there are only 1, 2, 3 unknowns. So actually this is a plane force system 2. So it also has 3 equations, you know, 3 equilibrium conditions, sigma x equals 0, sigma y equals 0, and sigma m some point f equals 0, you know? So these 3 equations also can find 3 unknowns. So that's what the method of imagining section all about, you know? So this method is very smart and it can quite simplify our process of calculation because we do not need to use the method of joint to find 1, 2, 3, which is not necessary to find force 5, 6, these internal forces. No? So if you guys can understand this principle, then we can use this. So because at this point, A prime, you know, A prime, actually when we cut, we can just use this as 4, as 5, as 6. So actually this is A prime. To denote these 3 internal forces, right? So because this point has 2 unknowns, so it's very smart, very clever. We can use this sigma ma prime equals 0. So we give this moment equation first. Then we can just use one single equation to find 1 unknowns, you know? Because when we give this equation, we do not need to consider P as 6 and as 5, right? So let's give this equation together. So because this S4 along the positive direction of X, so this force will have a CW moment to point A prime. Can you guys figure out its direction correctly? So this S4 will have a moment along CW direction. So this will be minus 1. So we have minus S4 and H actually is known. So we have minus S4 times H. And this XA, although it's zero value, but if it's not zero, because its application line through this point A prime, it also has zero moment to this point A prime. So we only need to consider YA. So once again, we can find actually YA will also have a CW direction moment to point A prime. So we have another minus here, YA times A, because the length of these triangles will be A. So we have this sigma MA prime equals 0. Then we can easily find S4, right? Because YA we know its value. Then this S4 from unknown change into what? Known. So we only need to find S5 and S6. We have used this equation once. We have two equations left to be used, right? So we give sigma y equals 0. Let us give this equation together. So we have YA here, maybe I can write YA, this one do not need to consider. So this, maybe if this is alpha, we will have S5 times cosine alpha. No, it will along x direction. It should be sine alpha. So plus S5 times sine alpha and minus p, because p along the negative direction of y. S6 along horizontal line, so do not need to consider. So we have this. So we can verify, so YA plus S5 times sine alpha minus p equals 0. See, our equation is correct. Then we can find this single equation only one unknown. So we can find using or from this equation S5 from unknown changed into known. So we only need to figure out the magnitude of F6. So we can use what? We can use sigma x equals 0, right? Sigma x equals 0. Once again, you guys please follow me. We will give this equation by ourselves together. So we give xa here, right? And plus S4 here plus S6 here and plus S5 cosine alpha, right? Because S5 cosine alpha will along the positive direction of x equal 0. Am I right? It should be correct. So we have S6. Actually, S6, we have axis here as well, as well cosine alpha here, as 4 here, but its equation have no xa because actually we know xa equals 0, right? So actually we have the correct equation. See, this is the final equation. From this, we can find S6. So this is the so-called method of section. No? So this method is very smart, is very useful, but in some cases you should. It depends, you know? Is this the best method we should use? It depends, you know? It depends. So you should according to the problem you encounter, right? Maybe you cannot find a proper section which can expose all the internal forces of your member. you are asked to calculate, right? But anyway, you guys should know the principle of this kind of method, right? That's how the trust, how to find some members' internal forces. We have two methods to select, just according to the real situation. Maybe we should use the method of joint, right? Maybe we should use the method of section. So I think just to finish up this section. After we finish this, we have what a summer you should know. So the judgments of internal forces of special element. What is special element? 特殊的杆，特殊的杆，no， 特殊的杆。So if no load acts on a two-element joint and the two elements are not collinear like this, then the internal forces of them are zero. So we call that members are zero members. Zero members. In Chinese, we call that 零杆。Maybe this is a little bit difficult for you guys to understand. If you cannot understand what I'm talking about, it's fine. I hope you guys just have the impression that Teacher Fang has mentioned that this kind of special element. If you can understand, that will be very great, you know? So you can find if we have two member along this different condition, because this a single knot, there are no action forces. So actually, because we have sigma x equals 0, sigma y equals 0. So if these two equations to be applied, then the only answer is the S1 equal S2 equal 0, right? Can you guys understand that? So you can think by yourself, you can take your time. It's true, right? So if S1 not equal S2 not equal 0, then these two equations cannot be true. So this will be controversial to the equilibrium of a plane concurrent force system, right? So you guys can think about that. Let's see the second summary. If no load acts on a three-element joint, and two elements of them are collinear. So this time there are three-element joint. The third is the zero element, you know? Actually, because you just need from these two equations, we have sigma x equals 0, sigma y equals 0. You know, so we can first find from sigma y equals 0, we can find S third must equal 0. Why? So if let's say this angle is alpha, so when we give this sigma y equals 0, we have S third times sine alpha equals 0. There are no other forces along the vertical line, vertical direction. So sine alpha cannot be 0. So if this equation equals 0, the only answer is S third itself should be 0, right? So S third equals 0, then it should be 0 member. It has no effect on this knot, you know? So the third is the 0 element because S1 and S2 collinear, right? So can you guys understand this? Actually, this S third can be any angle. This angle is more often will be alpha equal 9 degree, right? So which is perpendicular. So the third summary, if no load acts on four elements joint and two pair of them are collinear. So this S1 collinear with S2 and S4 collinear with S3. But this one is very pretty difficult to understand because we can think this is alpha and this is alpha, right? So we can just use these two equations, sigma y equals 0 and sigma x equals 0, try to figure out by ourselves. So when we use sigma y equals 0, we have S4, S4 times sine alpha. This component will along positive direction of y. We also have f third sine alpha, but it's a negative, so it have minus. So we have s third sine alpha equals 0. So it tells us the internal forces of each pair are equal in magnitude and of the same character, So you can find we have equation S4 minus S third times tan alpha equals 0. So we have the conclusion S third will equal S4. So from the same reason, we can from sigma x equals 0. So we have S2, right? Plus S4 times cosine alpha minus S1 minus S third cosine alpha equals 0. Because S third equals S4. So this one and this one will be eliminated one to each other, right? So we have S2 minus S1 equals 0. So once again, we have the same conclusion that S1 should equal S2. So there are three summaries. Maybe it's a little bit difficult for you guys to understand, but it's fine. Please, you guys have the impression that Teacher Fang has mentioned this special element here, right? It just need you guys know something a little bit. The more the great. If you can totally not understand, it's fine, right? It's fine. So let's move on anyway. So we have a very interesting example. So actually, we can find P is active force acting at joint A, and D is vertical distance from this point to this point. Determine the internal forces of rods ABC. So first a glimpse to this figure. When we just look at this structure, we find it very complicated. But through the three summaries we just mentioned, you can find actually from the rightmost knot. So, there is one knot, only two member without any other active forces on this knot. So this one will be 0 element. This one will be 0 element. So once again, there are only two members at the single knot. Then this one will be 0 element. This one will be 0 element. Then this knot also fulfill the requirement. One knot, two member, right? Two members. So this one is 0, and this one is 0. So we have the answer SD equals 0, right? So once again, we find this one, the one single knot, two members. So this one is 0, this one is 0, So this time, this knot originally have 1, 2, 3, 4, 5 members, but we find 3 of them are 0 members. Then it also fulfills the requirement, one knot, 2 members. So this one is 0, this one is 0 members too. So we have SC equals 0, right? And we also find that actually this point, two members, two of them collinear. So this one will be zero, zero members. So we have SA equals 0. No? So we found that SA, SC, SD all equal to 0. We only need to find SB. You see? We only need to find SB. And here, because this also a knot, one single knot with two members, so 0, 0. Right? So only have what? Only have this. You can find 0, 0, 0, 0, actually only have this, right? This one not 0, this one 0, this one 0, this one 0. So only this, this, and this. Then it's quite easy to use the sigma x equal 0, sigma y equal 0 to find SB equals this one. So we do not require that you guys can understand, use this so-called special members to simplify our examples or our problems. But I hope you that have an impression, right? We still have some time, but we have finished the final content of this chapter. We have talked about plane trusses, right? Plane, plane trusses, right? We talk about two methods to find or to calculate its internal forces. We also mentioned some summaries about special members. Try to tell you guys how to figure out which member is zero member. If you can, it's very great. If you cannot understand, it's okay. Don't worry about that. Okay, so let's move on. The final one, let's do a very short summary. Analysis, method of joint. This is convenient when the stresses in all elements of the truss have to be determined. That means if we are required to calculate all the internal forces of all the elements on the truss, so we can select this method first, right? The method of section, this is convenient in determining the stresses, not the stresses, not the stresses, actually should be internal forces. Maybe you guys cannot understand what is stress. Actually, we can tell you guys in advance. It's content we will learn next semester. We have normal stresses, sigma equal maybe S1 is general forces of member at its area of section. We can find its stresses. So actually, because this is always known, if we can find the internal forces, actually we can find stresses, stresses. We call that 应力 or stresses. So that means, at this time, you guys can only know that this is convenient in determining the internal forces in some individual members, not all, notably for verifying results, right? And before the calculation, assume first all element to be under tension, under tension. As I say that it will be stretched at two different points, right? If the result is negative, it means the element actually concerned is compressed, opposite to the direction assumed. We do not to recalculate that. We do not need to repeat the process of calculation. We just need to know that our assumption is not correct. It actually opposite our assume its direction, right? I think that's all for the plane trusses. Actually, this is the problem. Actually, I'd like to be a homework for you guys. But anyway, I think it's very difficult for you guys to finish by yourself. So I decided to finish this by ourselves together in class. You know, there are two problems. When we finish the two problems today, if we still have time, we will move to the new chapter, talk about mortar friction, friction. I will, today we don't have homework for you guys, but we'll do this homework together, right? So please, you guys, please pay attention to and listen to me, try to think, follow me, and try to understand how to tackle this kind of problems, right? So first, please, you guys see this picture. It let us determine the reaction force on point A, C, on point AC and roller BD, right? As shown in this picture, actually we can call that a force system, our plane force system, because we have bar AC, right? And bar CD. So these two bars have a common point C. Use the pin to link to each other, right? So actually, this is a force system, and we also should figure out which type of constraint on this problem. We find actually A is the fixed support, and B is the roller support. C is another pin, right? And D is another roller support. So let's see our known. So this is, do you guys have some concept of this? We call that this linear distribution force. That means, it means Q equal 10 kilonewtons per meters. So that means, how do we treat these loads like this? We just use, please focus my conclusion. We use the resultant force FQ, which equal the area of this ship. So if we consider the whole part of this distributed Q, then FQ should equal because this shape is rectangular, its length is 4 meters, right? 4 meters times its Q, right? Because this head means its distribution. So Q 10. So this 4 meters and this is kilonewtons per meter. So we can eliminate meters here. So this will be 40 kilonewtons. And its action will be middle of its whole length, right? That means this FQ will acting on this point. So that we should tell you guys in advance. Then we should do the force analysis and find the correct process to figure out the reactions at A, B, C, and D, right? Can you guys follow me? Can you guys understand what I'm talking about?
Yes, yes, love.
Okay. I will try to slower my speed. I hope you guys can totally understand how to tackle this problem. You see, actually, I do some preparation before our class today start, right? So actually, we can give this FAY, FAX, FD here, just according to its constraint, and FD here. So if we select this two part as a whole object to be studied, because we only have three equations, once again, a plane force system, we have sigma x equals 0, sigma y equals 0, and some point moment equation equals 0. So only can tackle or solve three unknowns. So you can count it by yourself. 1, 2, 3, 4. Right? We have four unknowns. So we cannot select the whole object to be object to start it, because there are four unknowns. We only have three equations. So we have to select one part of the whole system to start it. So let's say, actually this solution here, we select bar CD. So please, you guys try to listen to me. Try to listen to how what my description of our process. So we can select bar CD and try to give its FBD, free body diagram. That means we imagine we free this part CD from the original system, right? If we try to, you guys should know this process is imaginary, not for real, right? So if we try to free this city from the original system to here, we have to remove this constraint and this constraint. So we should give the reaction forces accordingly, according to the type of the constraint at C and at D, right? So because at point C, it is a pin, right? It is a pin. So we give FCX here, FCY here. And this moment is active moment. We just redraw it here, because this D is another roller support, FD, so we can draw here. Then you guys can find, then I will try to change my pen's color to let you guys help you easy to understand. You see? So we can call that is the subsystem, right? Subsystem. Because the whole system is in the condition of equilibrium, then the subsystem also should be in the condition of equilibrium. Then this linear distributed force will also should be tackle it. So it will have FQ, its magnitude equal this subpart, a half one, its area equal its half length, so 2 times Q, which is 10 kilonewtons per, will equal 20 kilonewtons. Its action position will be half the whole length, or midpoint of this whole length. So we can just change this one into a concentrated force FQ, right? So we use this FQ to denote, to tell you that actually this FQ will have the same effect to the bar CD. Then it is a subsystem in the condition of equilibrium. So it also have three equations, which is sigma x equals 0, sigma y equals 0, sigma some point AF equals 0, also have three equations, though you can check it. 1, 2, 3. We only have three unknowns. We have three equations, we can find this. Can you guys understand that? That means we can find the three unknowns. We can find its magnitude. So first, we can use this, right? So we give this sigma MCF equals 0. Why? Because at point C, we have FCX, FCY. Although we do not know the magnitude, but when we select point C as a point to give moment equation, we do not need to consider these two guesses this time, right? So it is a trick, a 技巧, right? It is a trick. So we can say from the rightmost to the left until to point C, we have this equation. So we have FD times the whole length, 4 meters. It will have CCW direction moment to point C. And this M is active moment. It's along the CW direction. So it will be negative. So we minus M. Its magnitude is 40 kilonewtons times M, times meter, right? So this one, then FQ. You see, FQ at this position, its length, distance from this point to this point will be 1 meter, right? It will have a CW, moment to point C. So we have to minus FQ times 1 equals 0. Can you guys understand this equation? Can you? Does anyone hear me? What are you guys doing? Are you guys?
Hello.
Okay.
FK into one. We did it.
Can you still follow me?
Yes.
It's very noisy for your voice. I cannot hear your voice clearly. Can you just use typing the message on here? Maybe I can help you know. Okay. Ho Yin tell me you can you can follow me. It's great. It's great. Okay. So I'm sorry. So let's continue. So use this equation, we can find FD, we can find actually FD. It will equal a quarter, M is 40, right? Plus this FQ is 20. So it will be 15 kilonewtons. See, we just use this, find FD, because it require us find ACBD. So we can use the other two equations to find FCX, FCY. So we can use sigma x equals 0. It's very easy, can find actually FCX equal 0, right? Because there are no any other forces along horizontal line. So when you use sigma y equals 0, we will have FCY. No, FCY and plus FD minus FQ equals 0. So here you should remember, when we give this kind of force equation, we do not need to consider these couples, because it is a couple. It don't have any effect on the sigma x and sigma y, right? So we have FCY minus FQ plus FD. So we can find FCY actually equal FQ minus FD. So which is FQ 20, FD 15. So it will be 12 kilonewtons. So you guys can find, actually we have finished the point C and point D, its reactions. So how we figure out FAY, FAX, and FB, we have two choices. So I will tell you guys. So the choice one, we can this time select AC as an object to be studied. So we have FAY here, FAX here, and we have FB here. We also have this one, which we should tackle just like here, right? Just like here. And we should, you guess, we should give, because here point A, point B, and point C. So here we should remember from the action and reaction point of view. So we should give FCX prime here and FCY prime here, which these two one will opposite to here. So that means FCX prime will equal FCX equal 0. FCY prime will equal FCY equal 12 newtons. So, I will change our my pens color again. So this time maybe we use green color. So you guys pay attention to here. So you guys pay attention here. You can find from this sub fault system. So once again, we can tackle this FQ. It also equal 20 kilonewtons, just like this, because it's symmetrical and its position it have a distance here, right? Also 1 meter to point C. So you can find from this subsystem of AC, it also is one unknown, two unknowns, and third unknowns. We also have two equations, sigma x equals 0, sigma y equals 0, and sigma maybe AF. It's hard to write here. Sigma AF equals 0. Then just small like this, we can use this three equations to find FAY, FAX, FB, right? Then we will finish our requirement, right? So this is so-called first choice. The other choice, let me tell you guys, the choice second, number two choice. What is number two choice? This time we can select the whole part as an object to be studied. Why? Because after we use this subsystem, we have find the magnitude of FD successfully. So this time we know actually FD equal 15 kilonewtons. This time, because when we select the whole AC and CD as the whole part to be studied, so we only need to figure out this total FQ will be Q10 times whole length 4. So this one will be 40 kilonewtons. And point C, it changed into internal forces, so we do not need to consider it. So you can find we have this whole part have three equations, right? And we also only have 1, 2, 3 unknowns. So this so-called choice second, we can finally find FAX, FAY, and FB. So because we don't have many times of today, so I hope I can let this be your homework today, right? Actually, we just talk about how to finish all the task, but I leave something for you guys to finish by yourself. Okay? So this is our homework today. So I hope you guys can totally understand what I'm talking about and select one of the choice to finish the calculation of FAY, FAX, and FB, right? So we only have three today's class. So there another problem. I just mentioned it's not our homework. You guys do not need to finish this one because I find it little bit difficult. 比较困难, right? But actually it's an example of a plane trusses. So I can tell you from the first glimpse, 乍一看, we can find actually, because this is a fixed point, this also is a fixed point. We can find because here we have FA, here we have FAY, we have FAX, here we have FAX, FCX, and this should be vertical FCY. So it's hard. It's very hard because we only have three equations, We only have three equations. How can we find four unknowns? Then we can find, if we select not C to be started, you can find actually here we have FCX. Here we have FCY. Then we have SBC, right? Internal forces of this one. And we have vertical summary of because we can easily find actually SBC equal FCX, right? SCD equal what? FCY. Then we can just imagine that we cut this to one off, then it will only have this, maybe as BC, and this as CD. Then we can use the method of joint and finally find out the answers. So I just talked you about how we figure out how to do the calculation, but you guys do not need to finish this one because it's very difficult. And I think that's all for today. We only have one homework. Please, you guys finish the left things, right? That's all for today. 今天就到这里了 ，OK， 下课吧，拜拜，拜拜 ，you guys。拜拜，拜拜，
Bye bye, teacher.
拜拜。See you next
Bye bye,
time.
teacher. Bye bye, teacher.
Okay. Thank you, all you guys.
See you Monday, teacher.
Thank you, sir. Thank you.
Okay, thank you. Bye bye.